fall, we learned how to solve systems of equation by graphing. Now we're going to learn why we're solving systems of equations, and we're going to learn two other methods. So we're going to go back to that treadmill problem that we looked at in class that you all got the chance to solve at your boards, unless you were absent, and then you would have missed that opportunity. So I'll refresh kids that were absent that we looked at this Peloton treadmill, and that Peloton treadmill cost $5,995, and then it had a monthly fee of $44 a month. So I'll circle that in red here. So most of you at your boards were able to write this equation. You said y had to be 44x plus 5,995. And you tried different numbers for x, meaning remember that x was the months that you had it, and figured out how much it cost after a year and how much it cost after 2 years, and so on. And then when we looked over at the Technogym treadmill, you saw that it cost just an outright $12,350. We didn't have to finance it, so we were not looking at a monthly fee. So the equation for that would be y equals 12,350. And most of you didn't write that equation because you just knew the treadmill cost 12,350. But this is a good time to remind you that we learned about horizontal and vertical lines. So we learned if something was y equals, we knew it was a horizontal line. So on the next slide, I'm going to show you the graph that will show you exactly what these two things cost compared to each other. It's really cool. So this is the graph of the treadmill, and I want to orient you to what it actually is saying. So you'll see down here that I have the months, so it's counting by months, and then the dollars. And you're going to notice that intersection point that's familiar when we graph and solve by graphing. This is my intersection point. So keep in mind, we're looking at months. Remember, that's our x value, our variable. And then we're looking at dollars. That's our y variable. So if we go to this intersection point, we see that our x variable, which is months, so months, and our y value, which is dollars. So after 167 months is when it is a break-even point. So you can see, and if you kind of get acclimated here, we can see that the one that is rising starts off at that 5,900 and something, and then it goes up and up and up. So it starts here, and it just keeps rising because it's charging $44 a month. Remember, $44 a month is its slope, if you will. Every month it's going the rise over the run, $44 for 1 month. And it just keeps going. It's not going to stop. Meanwhile, the Technogym starts up here at this fixed number, and it just keeps staying there. Nothing else goes into it. It just has a price. And eventually, after 167 months, they have the same amount. So you can ask a whole bunch of questions around this. When will the treadmills cost the same amount? Well, after 167 months. You might say to yourself, well, 167 months, I wouldn't answer that. I would change that into years. And most of you found that it was almost 14 years, so approximately 14 years when you did this in class. When will the Peloton be a better deal? Right up until 13.9 years or 167 months. So I'm going to say up till about 14 years. So less than, there's our symbol, 14 years. When will a Technogym become a greater deal? A better deal? And I would say, let's go ahead and round to that nearest whole and say 13.91 months. Well, it's really, or years, it's really greater than 14 years. So as long as you plan to hold on to it longer than 14 years, you're probably making a better choice to get the Technogym. So why do you solve systems of equations? To solve real world problems. Don't lose sight of that. That is the point of the whole thing. But we do have to know how to do it in order to solve those problems. So I'm going to teach us that. So we learned in the fall how to solve a systems by graphing, but it's been a little while. So I'm going to go ahead and review that with us. And I'm going to put my first one in red and my second one in blue. And you've demonstrated recently that you're pretty comfortable with graphing in our conversations, but let's just make sure. So we know that this is y equals mx plus b. And we know our slope is rise over run. And we know our y-intercept is that b point. So y equals mx plus b. We've done a lot of work with signs now, so we know this is plus and negative. So we're going to start down here on -1. And our rise over our run, remember, 3 over 1. So we're going to go up 3 and over 1. Up 3 and over 1. I do not have the luxury of having a ruler with me right now, so I'm going to plot a lot of points. 1, 2, 3, and over 1. 1, 2, 3, and over 1. And you might recall from the fall that the more points you plot and the more accurate your line is, the better chance you have of actually finding the intersection point. So I'm going to keep it as is right now, and I'm going to plot the next one. I'm not going to show that this is plus a negative because most of us don't need that now. I know that that is a -7 that I start at. And remember that your slope, if it's negative, instead of rising, you go down. So you're going to go down 3, 1, 2, 3, and over 1. Let's get the right color there. Down 3 and over 1. And if you want to get some points on the other side, remember, you reverse both. Up 3 into the left one. I just got lucky. I found my solution point. So I'm going to go up into the left one. And I'm going to go ahead and stop making points because I have enough that I can graph. So I'll just call this point 2, and I'll call this point 1. And I don't have to be perfect now because I know exactly where that intersection point is that I will put on here and say that that intersection point is -1, -4. So that is where they overlap. That's where both of them will overlap. If we were looking at something with a scenario, that's where they're the same. Now this is where it gets kind of fun because this is the new stuff. You know how to graph. But now we have learned how to change things to standard form. So I'm going to erase these extra bits here that I used. And we can use something called elimination. So y equals 3x minus 1. Let's change that to standard form. Now, keep in mind, in our work, we have changed from standard form to slope-intercept form, but there's nothing holding us back because standard form is just ax plus by equals c, which means our x's and y's will be on the same side. Right now, they're on different sides. So I'm going to put my 1y here just to make it easier for me, and I want to move my x's. So recall that I would subtract my x's, and we don't line them up because they're not like terms, but we end up with -3x plus y, or 1y, equals -1. We just moved our x's. So that's our first equation. And then I'm going to do the same thing with the second one. So this is why being great with our signs is really important. Y equals -3x minus 7. So again, make it 1y, and you would add your 3x's this time, and add your 3x's, and I'm going to put it right underneath the first one and watch what happens. So I end up with 3x plus 1y equals -7. Now I'm going to make this big for a minute so that you can notice something. If I were to do just a normal math problem of -3 plus 3, you would quickly see that that equals 0. So -3x plus 3x is going to cancel out. So what we're going to do when we solve something by elimination, and we'll learn a lot more about this, this is just a teaser to get you started and see the power in it, is we're going to add these two equations together just like we would a normal number problem, like -3 plus 3. So if we add them together, our -3x and our positive 3x are going to cancel out or be eliminated. And our 1y plus 1y is going to become 2y's. And our -1 and our -7 will be -8. This is so great. Now we have a one-step equation that we can solve, and we see that y equals -4. That is cool because look at what our answer is when we graph. It supports that answer. Y is -4. So you might ask, well, how will I find out what x is then? I know y is -4, and we're pretending that we never saw those equations at the top. We're only going to look at the ones we started with that we eliminated from. And what you would do to find your x value is you pick either equation and you plug your y value in. So I'm going to pick the second one just because it has a positive 3x. I don't know why, but it doesn't matter. I can pick either one, and I would write that equation down, and I'm going to replace my y with a -4. So I'll have 3x plus 1 times -4 equals -7. And this is that plugging in for variables that we're very familiar with. It's like checking, and we'd have 3x minus 4 equals -7. You should see, oh, I have a two-step equation, so I'm going to add 4 to both sides. And I'll have 3x equals -3. Divide by 3 on both sides, and I have x equals -1, which better match what I got, and yes, it did. So this is a method called elimination. We'll spend a lot of time with it. And what you use it for is when you have an equation where you've got both of them in standard form, or you've chosen to convert both into standard form. Let's look at another problem. So this problem asks us to solve by graphing. Okay. I want you to notice that this is in standard form. So we can't solve by graphing until we put the first equation into standard form. Luckily, we know how to do that. We want to get our x's and y's on the same side, or from the same side onto being on separate sides. So I would subtract my x. You might put a 1 there to help you. And then you'll have your -2y equals -1x plus 2, because we're going for y equals mx plus b. Divide both sides by -2. Cancel out, and we did this last week for all of our work, and we end up with 1/2 x minus 1. So now I'm ready to graph. What I'd be graphing is equation number 1 and equation number 2. So we're going to do that. It's interesting that it just so happens the ones I've picked are opposite slopes, one negative and one positive, but also just the same version of each other. So 1/2 x minus 1, we would start down here at -1, and then rise 1 and run 2, and rise 1 and run 2, and so on. So I've got my points. My second one, we start up at 5, and it's negative, so we go down 1 and over 2, down 1 and over 2. I have my intersection point, so now I can just quickly make my line. So this would be equation number 1, this would be equation number 2, and we know our intersection point is going to be 6, 2, x, y. Alrighty, now I'm going to introduce you to another method, and this is the last method we'll learn. We'll learn graphing, elimination, and something called substitution. So for this, I'm going to erase so that we have a clean set to work with. And this is where we're going to get to practice all of our work with distributing and all of the other things we've learned. So I have x minus 2y equals 2. I'm going to write this again. And I want you to notice that I have something else. I have y equals -1/2 x plus 5. So what I'm going to do with that is I'm going to substitute it in for my y down here. It's just a different way to represent the y. we know that I'm looking for where these two systems, these two lines intersect. So the y is going to be the same, and it says y is negative 1/2 x plus 5. So I'm substituting that in. So watch. I'll have x minus 2. Where I used to have y, I'm now going to have negative 1/2 x plus 5. So I need to put it in parentheses because y is now being replaced with something bigger, and it's going to equal 2. Now, what you want to notice here is this is what we've been doing all along. We've been spending all our time distributing and working with parentheses. And so I'm going to go ahead and do it. So 1x, some of you like to see plus a negative 2. Some don't like that anymore. You can see it on your own. So I end up with 1x. I'll distribute. 2 times 1/2 is just 1, and a negative times a negative is a positive. So 1x plus 1x. And now 2 negative times 5 would be negative 10. So plus a negative 10 or minus 10, either way. So I now have x plus x. My like terms is 2x plus negative 10 equals 2. This is where I prefer not to do plus a negative. I think it's better to have just one sign because it's easier for me to recognize how to solve this two-step equation by adding 10 to both sides. And I get 2x equals 12, divide by 2, and x equals 6, which hopefully is what we got. And look at that in our graph. 6 is our x value. Okay, you might say, well, how do I get my y value? Because these two overlap on each other, they intersect, I can go to either equation to get my y value. I now have my x value, so I can go to either equation. I'm going to go to the second one because it's solved for y. So I will say y equals negative 1/2 times 6 over 1 plus 5. If you're great with your fractions, this is pretty quick for you. You cross cancel and you get negative 3 plus 5, which equals 2. Ah, fantastic. I got my y equals 2, and that's what my graph says. So this is a method called substitution, and you use it when you have one of your equations in standard form and one in slope-intercept form. Works great. So what we'll spend the rest of our week and weeks after break on are getting good with substitution, elimination, and we'll review graphing a little bit. And we're also going to look at some real-world examples beyond the treadmill.